They say only the ocean's vastness can match the immensity of space. But have you ever seen the ocean at night?
Aye.
In the dark depths, bioluminescent creatures illuminate the surface with a ghostly light, creating an ethereal glow that mirrors the cosmos above. What's even more amazing is that these organisms actually produce their own light. And although we're still uncovering the secrets behind bioluminescence, it's already helping us explore the deepest parts of the ocean and might even be key to the future of space travel. Join us in this eye-opening journey as we delve into the captivating world of bizarre bioluminescence and reveal how it's transforming our understanding of the natural world. Some creatures almost seem like they've been beamed in from another world. Take the hatchetfish, for example. It has huge upward-facing eyes that make it look like it's staring straight up at the sky. Hatchetfish live in the mesopelagic zone, also known as the twilight zone, where sunlight begins to fade and the water temperature drops to near freezing. This extreme environment was long a mystery to scientists until they discovered the secret behind the hatchetfish-esque glowing appearance. Their skin contains special cells called photophores that emit light. What makes these cells unique is that they're semi-transparent, allowing the light to pass through and reflect upwards. As a result, the fish are perfectly camouflaged against the faint glow of the deep ocean's surface. To the creatures lurking below them, the hatchetfish practically vanish from sight, and those above them are dazzled by the mesmerizing display of twinkling lights dancing in the darkness. But the starry spectacle doesn't end there. The hatchetfish isn't the only creature that's mastered the art of celestial mimicry. Bristlemouth, a close relative of the hatchetfish, takes its camouflage a step further with a light-producing organ in its mouth. When the bristlemouth opens its mouth, the light spills out, mimicking the twinkling of stars. This clever trick confuses predators, making it harder for them to strike with a sudden snap. And the bristlemouth gets an added bonus. The starlight reflected from its mouth illuminates the surrounding darkness, giving it a better view of its prey. But perhaps even more remarkably, some bioluminescent organisms don't just camouflage themselves against the starlight. They actively use it for hunting. Take the vampire squid, for instance. This mysterious creature lives in the darkest depths of the ocean where sunlight is non-existent. Yet it has adapted to use the faint glow of distant stars to hunt its prey. The vampire squid's eyes are enormous and highly sensitive, allowing it to detect the smallest glimmer of light. When a potential meal swims nearby, the vampire squid strikes with lightning speed, snatching its prey before it can escape. But not all deep-sea creatures rely on the starlight for hunting or camouflage. Some, like the anglerfish, have developed their own ingenious ways to attract prey. The anglerfish is famous for its unique ability to lure unsuspecting victims within striking distance, with a glowing appendage that dangles enticingly in front of its mouth. This bizarre adaptation has made the anglerfish one of the most successful hunters in the deep sea. And yet it's just the tip of the iceberg when it comes to bizarre bioluminescence. There are many other organisms that have developed equally remarkable abilities to thrive in the darkest depths of the ocean. Take, for example, the dragonfish, which has rows of sharp teeth that light up like a neon sign. This dazzling display serves as a warning to predators that the dragonfish is not an easy meal. Other creatures, like the hatchetfish, have taken a different approach. They produce a chemical called luciferin, which reacts with oxygen in the water to create a glowing cloud around their bodies. This cloud serves as a smokescreen, confusing predators and giving the hatchetfish time to escape. The diversity of bioluminescent organisms in the ocean is truly astounding, and scientists are still discovering new ones all the time. These creatures have evolved a wide range of adaptations to use bioluminescence for hunting, camouflage, communication, and defense. But how do they do it? The secret lies in a group of chemicals called luciferins. Luciferins are produced by specialized cells in bioluminescent organisms, and when they react with oxygen, they release energy in the form of light. But the exact mechanism for producing and reacting luciferins differs among different species. For example, in the firefly, the enzyme luciferase catalyzes the reaction between luciferin and oxygen. In the jellyfish, on the other hand, the reaction occurs spontaneously. Bioluminescence isn't just limited to the ocean depths. It's also found in terrestrial organisms like fireflies, fungi, and bacteria. Fireflies, also known as lightning bugs or glowworms, are probably the most familiar examples of bioluminescence on land. They produce light in their abdomens, which they use to attract mates and ward off predators. Fungi, too, have mastered the art of glowing in the dark. Certain species of bioluminescent fungi produce light as a byproduct of their metabolism. This glow can be seen in forests all over the world, especially after a heavy rain when the forest floor is damp and humid. But perhaps the most unusual bioluminescent organisms are bacteria. Some bacteria are naturally bioluminescent, while others can acquire this ability through a process called horizontal gene transfer. Bioluminescent bacteria are often found in marine environments where they form symbiotic relationships with other organisms. For example, the bobtail squid lives in the intertidal zone and relies on bioluminescent bacteria to camouflage itself against the moon and starlight. But why should we care about bioluminescence? After all, it's not something we encounter every day. The answer is that bioluminescence can provide us with valuable insights into the workings of living things. By studying how organisms produce light, we can learn more about their physiology and biochemistry. We can also use bioluminescence as a tool to study the environment. For example, bioluminescent bacteria are used in wastewater treatment plants to detect the presence of pollutants. And in the field of medicine, bioluminescence is used as a fluorescent cancer marker. It can also help researchers track the spread of diseases and monitor the effectiveness of treatments. Imagine a world where doctors could identify cancerous cells with ease, track the progress of a disease in real time, and measure the effectiveness of new drugs. Thanks to bioluminescence, this future is closer than ever before. In fact, bioluminescent cancer markers are already being tested in clinical trials and showing promising results. Researchers are also exploring the use of bioluminescence in the development of new antibiotics and anti-cancer drugs. But perhaps the most exciting application of bioluminescence is in the field of space exploration. Bioluminescence has the potential to revolutionize the way we explore the cosmos. You see, bioluminescent organisms like fireflies and jellyfish produce light without giving off any heat. This makes them incredibly efficient light sources, much more so than traditional light bulbs, which waste most of their energy as heat. By harnessing the power of bioluminescence, scientists hope to develop new lighting systems for spacecraft that will last longer and use less energy. This could be a game changer for future space missions, allowing us to explore farther and stay longer without having to carry as much fuel. One day, bioluminescent organisms could even be used to light up entire cities. Imagine walking down a street lined with glowing trees and buildings powered by nothing more than the energy of living things. It might sound like science fiction, but it's becoming a reality thanks to the work of bioluminescence researchers. So the next time you see a firefly flashing in the darkness, or a jellyfish glowing in the ocean depths, take a moment to appreciate the incredible power of bioluminescence. Not only does it light up the natural world, but it's also illuminating the future of medicine, space exploration, and who knows what else. Who knows? Maybe one day you'll be able to witness the magical glow of bioluminescent coral reefs lighting up our underwater world like never before. Or maybe you'll get to explore distant galaxies powered by the light of bioluminescent plants. The possibilities are truly endless.